So let's move to divisibility by 3 and its powers. By 3 and its powers. Now for 3, the divisibility test is fairly straightforward. All you got to do is sum of the digits should be divisible by 3. Right, so that means if there is a number 472392, right, if I have to test whether this number is divisible by 3, what I will do is I'll add the digits. The sum is 4 plus 7 11 and 2 13 and 3 16 and 9 25 and 2 27. So sum of digits is 27. Now I can do this again, although I know that 27 is divisible by 3, but I add them up again. I get 7 and 2 9, right? The sum of the result is 2 plus 7 9, and 9 is divisible by 3. That means this number is divisible by 3, right? Similarly, the divisibility by 9 is again sum of digits should be divisible by 9, right? So let's test for this number again. 472392. The sum, as we had figured just a short while back, is 27, right? So if the sum is 27 and 27 as a number is divisible by 9, so this number is going to be divisible by 9 as well. However, what happens in case of divisibility by 27, let's say? Now in case of 27, clearly if we add up the digits, we will always see that they end up in the form of a multiple of 9 or not, right? So what we will do is, for this number again, 472392, what we will do is, if we have to test by 27, we can eliminate a 3 from this number. So what I'm suggesting here is, we break up 27 into 3 times 9, right? So what we do is, we divide this by 3 first, and we get 3 1 17 3 5 the 15 22 3 7 the 21 13 3 4 the 12 19 3 6 the 18 12 3 4 the 12, right? So this is the quotient that we get when we divide 472392 by 3. Now let's test this for 9. Test for 9, right? So by eliminating a 3, all I need to do now is I need to test the quotient for 9. Please remember, do not test the original number for 9, because if it is divisible by 9, then anyway it's divisible by 3. So I'm doing no service to myself by testing this quotient, this number, original number for 9. Once I eliminate a 3 from this, then I test my quotient for 9, right? So let's do this, the sum of digits. So it is 1 and 5, 6 and 7, 13 and 4, 17 and 6, 23 and 4, 27, right? So sum, interestingly, is 27, which is divisible by 9. Therefore, this number 472392 is interestingly divisible by 27 also, right? And similarly, if let's say we have to test for 81, then we'll use 9 times 9. So what we'll do is, we'll just divide this number now by 9, and whatever quotient we get, right? So let's do that. 472392, we divide this by 9, right? So we get 9 5 the 45, 22, 9 2 the 18, 43, 9 4 the 36, 7 79, 9 8 the 72, 72, 9 8 the 72, right? So we get this number when we divide 472392 by 9. Now we test this quotient for 9. So this is 5 and 2 7 and 4 11 and 8 19 and 8 27. So sum is 27. So very interestingly, this whole number 472392 is divisible by 9 into 9. That means 81 as well, right? So we can go on and on. So finally, to summarize, the way we do it for powers of 3 is, up to 9 we just add the digits, right? So for 3 you test the sum by 3, For 9 you test the sum by 9, but if it's higher powers, then you just keep eliminating the higher powers until you get a 9 or a 3 in the end, which you can test.